Hi guys, I'm Tongshan. Today me and my friends Siyun, Xingyi, Aikin and Valorant are going to share about the profound impacts of energy efficient strategies that have been implemented to the built environment on the global scene and meanwhile how it affects the energy demands for our case study building. So, let me introduce you to energy efficiency. In many areas, the built environment accounts for more than 70% of all primary energy use, with residential buildings make up roughly 42% of this total, followed by 34% for industrial and 24% for services. A substantial portion of this demand for energy comes from heating, cooling, and lighting. How a building manages these activities are critical in determining overall energy demand and practicing long-term sustainable tactics.
So now, let's dive into our case study, Hotel Marcel. Hotel Marcel is located in New Haven, Connecticut, nestled along the Long Island Sound on the northeastern coast of the United States. This area experiences a humid continental climate, characterized by warm, humid summers and cold winters. It also has moderate rainfall and northwest and southwest prevailing winds. The hotel is proximity to the coast, influences the climate, bringing higher humidity levels during the warmer months and contributing to the overall temperature yet moist conditions. Originally, the building was constructed in 1968 as Armstrong Rubber Company by Marcel Brewer, and in 2022 it was restored as Hotel Marcel. The architect preserved approximately 90% of the building's original mass, which significantly reduces the need for new materials, thus lowering embodied carbon. This transformation not only honors Marcel Brewer's architectural legacy, but also serves as a template for future sustainable renovations, demonstrating how historical buildings can be repurposed to meet modern needs while minimizing environmental impact and thus increase energy efficiency. Hotel Marcel is known for its cutting-edge sustainability. It is the first hotel to be Passive House certified, which is an international standard for energy efficiency, and the first hotel in the US to achieve carbon net zero.
So what makes Hotel Marcel an energy-efficient building? Well, one of its most significant design strategies is to use energy-efficient daylighting systems. Firstly, Hotel Marcel employs on-site renewable energy technology to generate electricity for its lighting fixtures. Hotel Marcel features over 1,000 solar panels on its rooftop and parking lot canopies, along with an additional solar field near the hotel, generating more than 575,000 kilowatt per hour annually. This solar energy powers 100% of the energy-efficient LED lighting all around. This can operate independently off the grid and ensures an emergency power supply to the lighting systems throughout the hotel. Furthermore, the surrounding of the building does not have any tall building that gives shade into the site. Thus, the conversion of solar energy into electrical energy can be maximized.
So, how else does Hotel Marcel manage to reduce their energy use and consume energy so efficiently? One of the main keys to this is the Vault server system, otherwise known as Power over Ethernet. There are over 3,000 lights in the building, and along with the blinds, they are all powered digitally and with low voltage systems using Ethernet cables. This technology ensures a more efficient power distribution, minimizing energy loss. Each artificial lighting fixture is also connected to a centralized management system, so each light is individually controlled and monitored, further optimizing energy use. Another feature that Hotel Marcel has employed to make their lighting system much more energy efficient than other hotels is that they use transformers at every light fixture, and this can reduce up to 30% or more of the electricity consumption and saving of about 50% on their utility bills. The LED technology used in the hotel is also inherently more energy efficient than traditional incandescent or fluorescent lights.
The hotel also features an array of automated shade features where the hotel guests can easily control the shades in guest rooms and meeting rooms to take advantage of the warmth of the sun during colder days and keep rooms cool by lowering the blackout shades during the heat of the summer. If desired, hotel staff can pre-program the shades to open and close at set times, including check-in and check-out. According to the architect Becker, the lighting and temperature control combined with the reduced energy consumption contributed by the automated shade solution have been an ideal match for a hotel that's setting new standards for sustainability.
Now, let's talk about some of the strategies employed for the harvesting of natural daylight in Hotel Marcel. In the night floor function space of the hotel, there is an internal courtyard and multiple light wells. This maximizes exposure of daylight to the interior function spaces and ballrooms. Since its renovation, the architects have added in 2 new central atriums which bring in sunlight from above, illuminating the central area and the surrounding conference room. The atria then continues as smaller light shafts that allow daylight into the inward-facing guest rooms as well. Not only that, the large low emissivity glass windows at every side of the exterior allow maximum penetration of natural light while reducing heat gain or loss. This creates a bright and inviting atmosphere that allows natural daylight to flow through the hotel, reducing the need for artificial lighting during the day. This is also why, comparatively, the building only uses 20% of the energy that a new code-compliant building will need.
The windows are also deeply recessed and oriented to maximize solar gain during winter while providing shade in the summer. As New Haven has a humid continental climate with temperatures ranging from -18°C during the winter up to 40°C in the summer. This passive solar design strategy helps regulate indoor temperatures, reducing the need for heating and cooling system and helps maintain a comfortable temperature all year round.
Finally, the success of Hotel Marcel's energy efficiency strategies are significantly shown in the post-occupancy evaluation here. The expected energy usage intensity for the hotel was 25.48 kBTU per square feet per year, but in reality, it only ended up being 18.8 kBTU per square feet per year. This is around 81% lower compared to conventional hotel buildings, which averages at 95 kBTU per square feet per year. This is equivalent to carbon sequestered by 184 acres of US forests in 1 year. Secondly, the expected energy consumption was lower than 810,000 kilowatts an hour. In reality, the energy consumption was only 575,000 kilowatts an hour. Hence, there was a 28% reduction in energy consumption compared to the project model. Reduction in energy consumption is around 28%, and energy sent back to the grid is around 226,000. In July 2023, a Michelin-verified reviewer stated that design was clean and chic. Spaces were well lit and well designed. Solar power was really impressive. Loved staying in a successful historic convention. In our final analysis, we have concluded that Hotel Marcel has set a new standard for green building and sustainable renovation. Architect Becker's energy-efficient strategies for the hotel, which emphasize the use of non-fossil fuel and clean energy resources to power its mechanical systems, have all been extremely successful.
So, that's all for our presentation. Thank you for watching.